Okay, let's start. So what about 13? So E is a dense subset of a metric space X and F is uniformly continuous real function defined on E. Okay, prove that F has a continuous extension from E to X. First, let's look for a counter example if the denseness or the uniform continuity is withdrawn. So first let's look at a counter example. If uniform continuity is withdrawn. So take f r minus 0 to r fx equals to 1 by x. So clearly this is continuous, but as you can see, f has no extension from r to r. Clear? So for this problem, let p belongs to x. Okay, and we have shown that if sends Cauchy sequences to Cauchy sequences, right? Wasn't it? Yeah, this is the problem. Problem 11. We have proven it. Let p belongs to x. Then Pn be a Cauchy sequence with limit n tends to infinity. Pn is p. Since, and this Pn comes from E. Pn belongs to E for all n. Since f is uniformly continuous by problem 11, if Pn is Cauchy in R, since this implies if Pn is convergent in R. So let xp be the limit, that is limit n tends to infinity if Pn is xp. Okay. Define f of p. We have to define f on p, na? Call it from x minus p. Then define fp by limit n tends to infinity fpn. Okay. Now let's check whether it is well defined or not. Now let's check the well definedness of f at p. So suppose Qn be another sequence with limit n tends to infinity, Qn equals to p. Qn is convergent if and only if Cauchy, right? Cauchy. This implies if Qn is Cauchy in R, thus let limit n tends to infinity if Qn is yp. Okay, we have to show that yp equals to xp. Okay, let epsilon greater than 0. So there exists n1, n2 such that if Pn minus such that n greater than n1 there exists delta such that if x minus y is less than delta, then fx minus fy is less than epsilon. Since limit n tends to infinity, Pn equals to limit n tends to infinity Qn is P, there exists N1 prime, N2 prime, such that if N greater than equals to N1 prime, then Pn minus P is less than delta. This implies Fpn minus Fp less than epsilon. This implies Fqn no. So if n greater than equals to n1 prime and n2 prime, then Pn minus Qn is less than equals to Pn minus P plus P minus Qn less than delta. This implies if Pn minus Fqn is less than epsilon. Let's do them epsilon by 3, huh? So if n is greater than equals to n1, n2, n1 prime, n2 prime, we have 1, 2, 3. So what is 1, 2, 3? This is 1, this is 2, and this is 3. Now if Pn minus Fqn, now xp minus yp is less than Fpn minus xp plus xp minus Fpn minus Fqn plus Fqn minus yp, right? This is less than epsilon. This implies xp equals to yp, because this is true for any arbitrary epsilon. Okay, continuity of f follows from the definition. Okay. What about this? What about 14? So just see this. This is 0, this is 1. Okay, this is 0, this is 1. Okay, draw this box, draw this straight line. Now you see one thing, the map is from I to I, right? So the graph of f is supposed to be like this. It can be like this, or it can be like this, or it can be like this. See, in all three cases there is a point. It can be this, it can be the terminal points, can be the points in between, where f cuts, where the curve cuts the y equals to x line. So that is the point, right? So what do we do? Case 1, if 0 is 0 or if 1 is 1. So then we are done, right? So then we are done. So case 2, if 0 not equal to 0 and if 1 not equal to 1. So see, if is a map from I to I, right? So if 0 has to be greater than 0 and if 1 has to be less than 1. Understood? Understood? Because f1 cannot be greater than 1 or f0 cannot be less than 0, right? So gx defined by fx minus x has g0 positive and g1 negative. So by intermediate value property, there exists x naught belongs to this, such that gx naught equals to fx naught minus x naught equals to 0.
তাহলে তো কন্ট্রাডিকশন তো।
Contradiction, we have proved it.
ও আচ্ছা, আমি ভেবেছি ওইটা ধরে নি।
Hmm. 15. Call a map. Okay, try this. Try this for 5-6 minutes. Not for 5, 6, 3, 4 minutes. At least think about it. How to do 15. Okay. Let's do it. So we will try to first see it pictorially. So suppose here is an open set. Okay, just look at it. If the graph is not increasing, what can happen? So suppose there is like this, suppose is a region. Now you take an open set here. What is the image? Right? So the image is, suppose this is A and B and this is C and D. So f of open CD, the image is what? Open A closed B, right? Because it attains the point of maxima. So it has to be monotonic. Okay. Understood what I am trying to say? If there is a point of extrema, then A will attain it. So if F will attain it, okay, if there is a maxima or a minima, F is not monotonic, then there exists a point x naught such that there exists a point x naught and a delta greater than 0 such that if x naught is equal to such that if has a local minima or maxima at x naught, that is there exists delta greater than 0 such that if x naught is equal to minimum equals to mean x belongs to x naught minus delta comma x naught plus delta. Fx or max x belongs to x naught minus delta comma x naught plus delta. So without loss of generality, let fx naught is a local maximum. We will show that if x naught minus delta comma x naught plus delta is not open. In particular, if x naught is not an interior point of f of x naught minus delta comma f of x naught plus delta. So if x naught is an interior point of f x naught minus delta comma x naught plus delta, then there exists epsilon greater than 0 such that f x naught minus epsilon comma f x naught plus epsilon is completely contained in this right. Then for see, this thing is inside this, okay? So for a with f x naught minus epsilon less than f x naught less than a less than f x naught plus epsilon, there exists b belongs to if x naught minus delta plus x naught plus delta, right? Such that if b is a, true, right? Because a is in this image, na? A is in this image. So there exists a b such that f of b is a, which is a contradiction, as if x naught less than if b for b belongs to x naught minus delta comma x naught plus delta contradicts the maximality of f x naught. Okay, so the proof is clear. The proof is clear now. See from pictorially, just see here. Maybe I should write it here like CD, okay, and this is my A, sorry, this is my B and this is my A. Okay, so clearly this A which is FB. This is not an interior point na, of this interval. This is a boundary point. Clear? This I think we have done. Simplicity. Every rational number x can be written in the form x by m by n. Or else you can try it at home. I mean, just try it the way we have shown that uh, jump discontinuity is try as jump discontinuity. If you can't do it, then let me know. This is an interesting problem. How about this? How to do this? So what's the problem? They are saying that if x is rational, they are sending x to 1 by n, where m by n is the reduced form. And 0 if x is irrational. So they say that f is continuous on every irrational point and has a simple discontinuity at every rational point. Okay, again, let's try for 2 minutes, 2 to 3 minutes, then see what can we do. Try for a while.
দাদা,
বলো।
আচ্ছা ওই সেটটা তো ক্লোজড বলে দিয়েছে, তাহলে এক্স জিরো তো ওই সেটের মধ্যেই থাকবে, মানে হিন্টটা যদি ফলো করি।
Where is the hint?
নিচেই লেখা আছে।
কি? I'm telling you to do 18.
ও সরি।
কি অবস্থা? Okay, so we can approach it in the following way. let P belongs to R, any point, okay. For epsilon greater than 0, there exists capital N belongs to natural numbers such that 1 by n is less than epsilon. That's true. Now, any, tell me whether you understand this line or not. Any interval around P contains only finite number of rationals m by n with n less than n. Is this line clear to you? Is this line clear to you? I mean, any interval means I am talking about any bounded interval. Is this line clear to you guys, please?
আর্কিমিডিয়ান প্রপার্টি থেকেই তো আসছে তো।
For any interval, suppose m by n belongs to say p minus delta comma p plus delta, which means p minus delta is less than m by n is less than p plus delta. Which means np minus delta less than m less than np plus delta. And since n is less and n is in the range, so clearly for this m comma n tuple has only finitely many choices, na? Because m can vary between these two, and m and n varies between these two, has only finitely many choices. True? Okay. So choose delta small enough such that mod x minus p less than delta implies fx less than 1. Can it be done? See, fx is 0 when x is irrational, so we don't need to worry about irrationals, right? And what is this thing? This is when x belongs to p minus delta comma p plus delta. So for it you can have only finitely many rationals. So what do you get? I mean, f of m by n is 1 by n, na? That's what they're saying.
ইরাশনাল নাম্বারে তাহলে ডিসকন্টিনিউটি চলে আসছে,
So
মানে
yeah,
p যদি ইরাশনাল হয়।
so basically we get this, no, rational discontinuity আসছে. By this we can say this, na, so f is continuous on irrationals.
না, কন্টিনিউয়াস হচ্ছে না ইরাশনাল,
কেন?
জিরো
F is,
ভ্যালু আসছে।
yeah, so f is 0 on irrationals.
ও আচ্ছা আচ্ছা,
And if
ইরাশনাল
has a simple discontinuity on rationals. Just I'm thinking something that just thinking. Okay, so basically you are excluding only those points. Understood? Understood? You are only excluding these points inside the bracket. Clear? See, for these points, for these points, for these points, I mean when m by n belongs to x p minus delta comma p plus delta and n less than n, then you get f of m by n is 1 by n, which is strictly greater than 1 by n, na? But it is true only for finitely many points. So apart from all points, I mean, so if you choose a delta close enough so that it contains none of this m by n with n less than capital N, it is true, right? You will have to find, I mean, understood what I am trying to say. So suppose for any delta, these points, I mean m by n belongs to this and n less than n, okay? Satisfying these two criteria, there are only finitely many points, right? So you choose delta so small that such that it contains none of those points, and then it is true. Okay, Shubrita was trying this. Yeah, go ahead. Try this for a while then. Yeah, try 19.
বলছিলাম যে
Hmm.
x0 তো তাহলে ওই মানে সেটটার মধ্যেই থাকবে যেহেতু ক্লোজড বলে দিয়েছে।
Just a minute, let me see. Suppose f is a real function
pn
with
যেহেতু
domain.
x0 তে,
No, just a minute. We satisfy intermediate value property. Okay. every rational R, the set of all X such that is closed. Okay. Proves that F is continuous. Okay. So they have taken X sequence Xn belongs to X. Yeah, Shubhrita, what is your argument? Why is X not in that? Xn is taken from where? Xn is any sequence converging to X naught. Okay.
ওই সেটটাতে আছে যে মানে সেট অফ অল এক্স উইথ এফ এক্স ইজ ইকুয়ালস টু আর। এক্সেল তো সেখান থেকেই চুজ করেছে।
Is it so?
নাও হতে পারে সেটাও।
What is their approach basically? So I mean, I think they are trying to say that suppose F is not continuous on R. Okay. So there exists Xn belongs to X naught, but Fxn doesn't go to Fx naught, right? So Fxn strictly greater than R, strictly greater than
হ্যাঁ
uh, Fx naught for some R and for all n, so on. I mean, so Fxn is greater than Fx naught. They have taken it, and they have taken a rational in between. Then, if Tn is R for some Tn between X naught and Xn, why is that? Yeah, for
ইন্টারমিডিয়েট ভ্যালু
rational, for
প্রপার্টি।
intermediate value property. Thus, Tn goes to X naught. Why?
টিএম তো ওই সিকোয়েন্সটারই সাব সিকোয়েন্সের মতোই তো।
No, why is Tn a subsequence of that?
মানে
No, I can't understand that line. Why Tn should? I mean, Tn was a single point, no?
আলাদাভাবে করি তাহলে।
For all n. Okay. I understood. They have taken x1 first, then for that x1, fx1 greater than r greater than fx naught, now they are finding t1. Okay, I understood. Okay, try it for 2-3 minutes, then I will show it. Try it for 2-3 minutes. So let f is not continuous at x. This implies there exists a sequence yn such that yn goes to x naught, but if yn does not go to fx naught, that is, there exists delta greater than 0 such that f of yn such that if x naught minus delta comma if x naught plus delta contains only a finitely many points of fyn, so without loss of generality, let xn be a subsequence of fyn, if xn be a subsequence of fyn such that if xn is greater than fx naught. Right, so fyn is either less than fx minus delta or greater than fx naught minus delta for all but finitely many yn. So without loss of generality, I am choosing, suppose for infinitely many yn, if yn is greater than fx naught minus delta plus delta, and I am taking those xn only. So for each n belongs to natural number, there exists Tn so first fix R belongs to Q such that if xn greater than R greater than fx naught. For each n there exists Tn such that Tn belongs to x naught comma xn, and if Tn is R by IVP. True. Since xn goes to x naught, we have Tn goes to x naught. So can I say this? Closure of this set. Can I say this? Hmm? Can I say this? I mean, this implies Tn belongs to F inverse R, right? Since x0 is a limit point, so this, but this set is closed. But as F inverse R is closed, x0 belongs to F inverse R. This implies Fx0 equals to R, which is a contradiction. So F is continuous. Okay. See, we will conclude the class today, and in the next metric space class we will try to complete this all the rest of the exercise. Okay. Why can't I stop recording?